So in this video, we want to look at rational, irrational, and decimal. Now, but before we talk about that, we need to understand the concept of the number line. The number line is a straight line that extends infinitely in both directions. When we say infinitely, the significance of this arrow shows that they extend in both directions infinitely. So with 0 in the middle, which represent the origin. So positive numbers, which could be integers, whole number, irrational number, and increases to the right. So what I'm saying is that positive number increases to the right. As a matter of fact, the whole number increases to the right. That's what it means in reality. And negative numbers decreases to the left. So this one is decreasing to the left. Generally, all the numbers decreases to the left, and all the numbers increases to the right. What I'm saying is that as we move from -5, -4, -3, there's an increase. What I'm saying in essence is -4 is greater than -5, -3 is greater than -4, -2 is greater than -3, 0 is greater than -1, 1 is greater than 0, 2 is greater than 1. So that is the concept. So different properties of numbers can be represented on the number line. So what are those properties? For example, here we have pi. Pi is an irrational number, and it is a number that doesn't terminate. It is, I mean, the decimals in go on and on, so it's not a terminating decimal as such. The same thing applies to root 2, but they can find their place on the number line. For example, we know that pi is 22/7, which is 3.142. So 3.142 should be somewhere around here. So the same thing applies to -2/3, √3, and so on and so forth. So different properties of numbers basically can be represented on the number line. So now let's now look at the different definition of terms that we are going to be using, and this definition of terms will be helping us in making decision when we have problems that involve the properties of numbers. So let's look at this definition of terms. Okay, so in case, okay, let me see if I can zoom it. All right, so no, so let's maintain it the way it is. Now we have what we call natural numbers. Natural number is a set of positive underlined whole numbers or set of all positive integers from 1 to 0. So when we talking about natural numbers, they are set of what positive integers greater than what 0. So natural numbers start from 1. So example is 1, 2, 3, 4. So they are set of positive whole number or set of positive what integers or set of positive or set of integers greater than 0. So those are the three ways by which we can define it. Then we have, so in case this property of number is presented in an example, you should know that you are going to be listing 1, 2, 3, 4 till infinity, depending on the condition given to you concerning the natural numbers. Then we have the whole number. Whole number is a set of positive or positive integers from 0. So the difference between natural number and whole number is the fact that natural number, right, are positive integers greater than what 0, while whole numbers are integers that start from what 0 till infinity, right? So they are all positive as well. We don't have negative whole numbers. I mean, in reality, they are set of all positive integers from 0. Then we have integers. Integers are set of all positive and negative whole numbers, right? When I say we don't have negative whole number, and I'm talking about in terms of definition basically. So they are set of positive or negative whole numbers, and I put something here. I said integers do not include fractions. The reason why they don't include fractions is because they are whole numbers, so they can be expressed in terms of ratio. And I said 0 is neither negative nor positive integers. I'll quickly explain that. When we're talking about zeros are in 0 is neither positive or negative integer. When we say negative integers are integers that are less than 0. For example, look at what we have here on number line. So all these numbers are integers. Let's close our eyes to the fraction we have here, because on number line we have different properties of numbers. Now any So when we say positive integer, when we say positive integers, they are integers greater than 0. And when we say negative integers, they are integers less than 0. That's what I'm trying to explain here. So negative integers are integers less than 0. So we take them from minus infinity to 1. So the highest negative integers you can have is -1, right? Then positive integers are integers greater than 0, as we have it on the number line here. So all of these are positive integers. These are positive what integers, right? And these are what negative what integers. So they are whole number less than 0. Positive integers are whole number greater than 0. Then what are real numbers? So real number is a combination of rational and irrational what numbers in a set. When we say rational numbers, these are numbers that can be expressed as a fraction, and they give a terminating decimal basically. While irrational numbers are numbers, right, that cannot, they can be expressed as fraction basically, but they do not terminate. So real numbers are a combination of rational. You can see this is -3.5, right? This is a fractional number because -3.5, if I move this decimal point here, can be written as what 35. That's -35 times 10 raised to the power -1. That will give us -35/10, because 10 raised to the power -1 is 1/10 raised to the power 1. So this is a what, a rational number. All right, so then we have -1/2 and so on like that. So what are rational numbers? Rational numbers are negative or positive integers that can be expressed as fraction. Fraction means ratio. E.g., a over b is a rational number where a and b are integers and b is not 0. So because if you divide a by 0, it's undefined. It will give you 0. Pardon me for that. So example of rational number was -3.5. Real numbers are just the combination. Why irrational numbers are a set of real numbers that cannot be expressed as a fraction or ratio of two integers, right? For example, when we say ratio of two integers, what we are trying to say is that they cannot be represented by terminating or repeating decimal. Example of such is pi, -√2, √3, and so on. So having a clear understanding of this definition of terms will be useful whenever problems are being solved in algebra. Thank you for watching. See you in the next video. Bye bye.